The idea that we have in mind is to create a quality assurance system. There will be a conveyor belt that will have parts going down. As parts are going down, we will make use of different types of sensors to conduct different types of tests on the parts to see if they meet the requirements we have set. The end goal is we want a system that can detect whether a part meets all requirements or does not, and then will send the parts that are built incorrectly to the defect box and the parts that are built correctly to the correctly built box.
An IR sensor has an emitter that sends out infrared light and a receiver that detects the reflected signal. When an object is in front of the sensor, the light bounces back to the receiver, which then triggers an output. Next, we're using a 3-color LED light. A simple circuit powers a 3-color LED light, with three 470 ohm resistors controlling the current from the DAC's digital output. Each color is connected to a separate digital output channel, allowing the DAC to manage the light's operation. We're using a color sensor. The color sensor has photodiodes with clear, red, and green, and blue filters that detect reflected light from an LED. It outputs a square wave where frequency depends on the color intensity. Two digital outputs, S2 and S3, select which color is measured, with higher frequencies indicating stronger colors. The output frequency is scaled using S0 and S1 with a maximum of 12 kHz. To ensure accurate measurement, the slowest speed is used.
Our first weight sensor, placed under the collection box at the end of the conveyor belt, automatically tracks the under of the sorted parts by measuring their total weight. This eliminates manual counting, ensures accurate inventory management, and preventing overflow. If the bin reaches capacity, the system triggers an alert, improving efficiency and keeping the production line running smoothly.
The stepper motor is a brushless DC motor that rotates in precise steps by dividing a full turn into equal increments. Inside the motor, there are 4 magnetic coils that must be activated in a specific sequence to move the motor forward or backwards.
Photoelectric sensor. A photoelectric sensor is a device that uses light to detect shape, presence, or orientation of an object. It emits a beam of light and measures the light that is reflected back or interrupted by an object. Emitted light then hits the surface of a part and the sensor detects the reflection. If reflection pattern matches expected standard of the part, then the part will be accepted, but if it's not, then the part may be defective.
Okay, so the building blocks of the vision system. First, we'll start off with a stepper motor that will be used for positioning the part onto an axis. Next, we'll have 2 servo motors, one for part sorting and one for part positioning. Then we will have 1 color sensor to determine the color of the machine part on the conveyor belt. We'll have 1 IR sensor to measure length or outer diameter of the machine part. We'll have 2 force weight sensors to calculate number of good and bad machine parts that have been sorted by the system. We'll need a transducer to convert changes in IR sensor and force weight sensor output resistance to a measurable voltage. We'll have a 3-color LED light to indicate the state of the conveyor belt. We'll need a DAC that will read analog signals from sensors and convert signals to real-time measurements. And we'll have 1 photoelectric sensor to detect part integrity and standard of parts. And a photoelectric sensor will output a digital signal that will be sent to the DAC. Below is the attached rough system sketch containing our proposed sensors and a physical idea of what the conveyor belt and system as a whole will look like.
The automotive industry is one of the bigger industries that takes advantage of quality assurance mechanisms. Since automotive vehicles consist of so many different types of parts, quality assurance tests must be done on all components to ensure that there are no defects and nothing goes wrong internally. It is a major part in automotive since people are driving these vehicles. If there are defects, people can get hurt, so it must be avoided at all costs. And that means quality assurance tests are done quite often. Some parts that tests can be conducted on are screws, fasteners, bearings, sensors, etc.
Manufacturing industry. The manufacturing industry can make a good use of this system. The system can be used on assembly lines to inspect things like screws, bolts, and other machined parts for defects. The system would ensure quality components are used, which in turn would improve product reliability. Ensuring that quality parts are used is very important in the manufacturing industry because when manufacturing, we want to make sure that our product is safe and reliable. This system does exactly that.